deploy wireless uninterruptible power supply, or UPS, systems that transmit power over the air using radio frequencies. This allows devices to be placed at a distance from the physical UPS. Install remote power distribution units, or PDUs, in the vicinity of the phone equipment. These PDU can be connected to the UPS via Ethernet cables, ensuring uninterrupted power supply. Utilize coaxial cables specifically designed for UPS compatibility. These cables transmit power and data simultaneously, eliminating the need for separate power cords. Consider Power over Ethernet, or PoE. Leverage PoE technology to power both phones and other network devices through Ethernet cables. This eliminates the need for additional power cords and reduces cable clutter. Install conduits or raceways to conceal cables running to the UPS while ensuring code compliance. These enclosures provide a clean and organized appearance. If code regulations permit, consider using an extended power cord up to 25 feet to reach the phone equipment. Secure the cord neatly to avoid tripping hazards. Mount a slim cable tray underneath a desk or shelf to route cables to the UPS without visible cords. Utilize furniture pieces with built-in power outlets to provide convenient and accessible power supply for the phone equipment. Install the UPS on a wall in a central location, allowing for easy access to both phone equipment and computers. When dealing with powering remote phone equipment from a UPS, there are several creative and practical solutions to consider, always keeping in mind electrical codes and safety. Firstly, a wireless UPS system can be employed. These systems use radio frequencies to transmit power, enabling phone equipment to operate at a distance from the physical UPS unit. While innovative, it's crucial to ensure that the wireless power transmission complies with safety standards and regulations, including frequency allocation and power limits. Secondly, remote PDU, or power distribution units, can be strategically installed near the phone equipment. These PDU connect back to the main UPS via Ethernet cables, providing a reliable and uninterrupted power supply. This approach combines the benefits of centralized UPS protection with distributed power delivery, reducing the need for long power cords. Thirdly, coaxial cables specifically designed for UPS compatibility offer another option. These specialized cables can transmit both power and data simultaneously, eliminating the need for separate power cords. However, it's essential to verify that the coaxial cables meet the power and data transmission requirements of the phone equipment, as well as comply with electrical codes for combined power and data cabling. Fourthly, Power over Ethernet, or PoE, technology presents a compelling solution, especially for modern phone systems and network devices. PoE allows both power and data to be transmitted over Ethernet cables, eliminating the need for separate power cords. This simplifies installation, reduces cable clutter, and provides a centralized power management system. PoE switches or injectors can be connected to the UPS to ensure a continuous power supply to the phone equipment. Fifthly, concealing cables and conduits or raceways is a traditional but effective method for routing cables to the UPS while maintaining code compliance and a clean appearance. Conduits and raceways provide physical protection for the cables, preventing damage and reducing the risk of electrical hazards. They also offer a neat and organized way to manage cables in commercial environments. Sixthly, an extended power cord can be used if permitted by local electrical codes. However, it's crucial to ensure that the extension cord is of the appropriate gauge and length to handle the power requirements of the phone equipment. The cord must be secured properly to prevent tripping hazards and comply with safety regulations. A hidden cable tray can be mounted underneath a desk or shelf to route cables to the UPS without exposing them. This approach combines aesthetics with functionality, providing a discreet way to manage cables in a visible area. Furniture with built-in power outlets offers a convenient and accessible power supply for the phone equipment. These furniture pieces are designed with integrated power distribution, reducing the need for external power strips and extension cords. The UPS can be installed on a wall in a central location, allowing for easy access to both the phone equipment and computers. This approach optimizes space utilization and provides a centralized point for power management. When implementing any of these solutions, it's essential to consider the following factors. Firstly, compliance with the electrical codes and safety regulations is paramount. All wiring and installations must adhere to local and national electrical codes to ensure safety and prevent electrical hazards. Secondly, power requirements of the phone equipment must be carefully evaluated to ensure that the UPS and power distribution system can handle the load. Overloading the UPS can lead to system failures and equipment damage. Thirdly, cable management is critical for maintaining a clean and organized environment. Cables should be neatly routed and secured to prevent tripping hazards and improve airflow. Fourthly, future expansion and scalability should be considered when designing the power distribution system. It's important to choose solutions that can accommodate future growth and changes in the phone equipment configuration. Fifthly, regular maintenance and testing of the UPS and power distribution system are essential for ensuring reliability and preventing downtime. The UPS battery should be checked periodically and replaced as needed. Finally, consulting with a qualified electrician or electrical engineer is recommended to ensure that the chosen solution is safe, code compliant, and meets the specific requirements of the phone equipment and the facility. In conclusion, powering remote phone equipment from a UPS requires careful planning and consideration of various factors, including electrical codes, power requirements, cable management, and future scalability. By employing creative solutions such as wireless UPS systems, remote PDU, PoE technology, concealed cabling, and strategic placement of the UPS unit, it's possible to provide a reliable and efficient power supply while maintaining a safe and organized environment. In the specific scenario of moving into a new building with a larger telephone or computer room, the challenge lies in extending power from the existing UPS to phone equipment located on the opposite side of the room. Several options can be explored, keeping in mind the avoidance of running a cord directly across the room in a trough, which might not be code compliant. One approach involves installing remote PDU near the phone equipment. These PDU would be connected to the UPS via Ethernet cables. This allows for distributing power without running long power cords across the room. The Ethernet cables can be routed along walls, ceilings, or under the floor, ensuring a neat and code-compliant installation. Another method is to utilize Power over Ethernet (PoE) if the phone equipment supports it. PoE allows power and data to be transmitted over the same Ethernet cable. This eliminates the need for separate power cords for the phones. A PoE switch or injector can be connected to the UPS, providing a centralized power source for the phone system. Concealing cables and conduits or raceways is another option. Conduits and raceways provide a protected pathway for the cables, keeping them out of sight and preventing damage. They can be installed along walls, ceilings, or under the floor, depending on the building layout. A hidden cable tray can be installed under desks or shelves to route cables to the UPS without visible cords. This approach is particularly useful in areas where aesthetics are important. If code regulations permit, an extended power cord can be used to reach the phone equipment. However, it's crucial to ensure that the cord is properly sized and secured to prevent tripping hazards. The cord should be routed along walls or under furniture to minimize visibility. A wireless UPS system could be considered. This would involve transmitting power wirelessly from the UPS to a receiver near the phone equipment. However, wireless power transmission technology is still relatively new and may not be suitable for all applications. Furniture with built-in power outlets can be used to provide a convenient power source for the phone equipment. This eliminates the need for power cords and reduces clutter. The UPS can be strategically placed in a central location to minimize cable runs. This approach requires careful planning to ensure that the UPS is accessible and that the cables can be routed safely and efficiently. Before implementing any of these solutions, it's essential to consult with a qualified electrician or electrical engineer to ensure that the installation complies with all applicable codes and regulations. The electrician or engineer can assess the specific requirements of the phone equipment and the building's electrical system and recommend the most appropriate solution. In addition to the above options, there are several other factors to consider when powering remote phone equipment from a UPS. Firstly, the power requirements of the phone equipment must be carefully assessed. This includes determining the voltage, current, and power consumption of each device. The UPS must be sized appropriately to handle the total power load. Secondly, the distance between the UPS and the phone equipment must be taken into account. The longer the distance, the greater the voltage drop in the cables. This can affect the performance of the phone equipment. Thirdly, the type of cable used to connect the UPS to the phone equipment is important. The cable must be properly sized to handle the current and voltage requirements of the equipment. It must also be rated for the environment in which it will be installed. Fourthly, the installation must comply with all applicable codes and regulations. This includes requirements for grounding, overcurrent protection, and cable routing. Fifthly, the installation should be designed to minimize the risk of electrical hazards. This includes using appropriate safety devices, such as ground fault circuit interrupters, GFCIs, and surge protectors. Finally, the installation should be inspected and tested by a qualified electrician to ensure that it is safe and code compliant. By considering all of these factors, it is possible to power remote phone equipment from a UPS safely and efficiently. The Remote Power Distribution Units, or PDU option, is a very viable one. Power distribution units, PDUs, are devices that distribute electrical power to multiple devices from a single power source. In the context of a UPS system and remote phone equipment, PDU can be strategically placed near the phone equipment to provide a convenient and reliable power source connected back to the UPS. Here's how it works. Firstly, the UPS provides backup power. The UPS serves as the central power source for the phone equipment, providing backup power in case of a power outage. Secondly, Ethernet cable connectivity. Instead of running long power cords across the room, Ethernet cables are used to connect the UPS to the PDU located near the phone equipment. Ethernet cables are suitable for transmitting data and power, especially when using power over Ethernet PoE. Thirdly, distributed power. The PDU distribute power to the phone equipment from a localized point, reducing the need for multiple power outlets and long power cords. PDU can be mounted on walls, under desks, or in equipment racks depending on the layout of the room. The advantages of using PDU are several. PDU simplify cable management by consolidating power distribution in a centralized location. They also improve reliability by providing a stable and regulated power supply to the phone equipment. PDU enhance flexibility by allowing for easy addition or removal of devices without disrupting the entire power system. They are also cost-effective. Using PDU can be more cost-effective than running multiple power cords across the room, especially in larger installations. When selecting PDU for remote phone equipment, consider these factors. Firstly, the number of outlets needed to accommodate all of the phone equipment. Secondly, the power capacity. The PDU must be able to handle the total power load of the equipment. Thirdly, the type of outlets needed. PDU come with a variety of outlet types, such as standard NEM outlets, IEC outlets, and USB charging ports. Fourthly, the mounting options. PDU can be mounted on walls, under desks, or in equipment racks. The remote PDU are generally a good option. Using remote PDU in conjunction with a UPS system can provide a reliable, flexible, and cost-effective solution for powering remote phone equipment. It also ensures code compliance and avoids the need for running long power cords across the room. Power over Ethernet is also a strong option for the phone equipment. Power over Ethernet PoE is a technology that allows electrical power to be transmitted along with data over standard Ethernet cables. This eliminates the need for separate power cords for devices such as IP phones, security cameras, and wireless access points. In the context of the telephone computer room, PoE can be used to power the phone equipment located on the opposite side of the room from the UPS. Here's how it works. The power source equipment C provides power. The C, typically a PoE-enabled switch or injector, provides electrical power over the Ethernet cable. The power device PD receives power. The PD, in this case the phone equipment, receives power from the Ethernet cable and uses it to operate. The Ethernet cable transmits both data and power. The Ethernet cable carries both data and electrical power simultaneously. PoE offers several advantages. It simplifies installation by eliminating the need for separate power cords, which reduces cable clutter and simplifies installation. It also saves costs. PoE can save costs by reducing the number of power outlets and electrical circuits required. It is also flexible. PoE allows devices to be easily moved or reconfigured without the need for additional power wiring. It also improves reliability. PoE provides a centralized power source, which can be backed up by a UPS to ensure continuous operation during power outages. There are different PoE standards, including 802.3F, 802.3Et, and 802.3B, which provide different levels of power. Firstly, 802.3F provides up to 15.4 watts of power per port. Secondly, 802.3Et, also known as PoE+, provides up to 30 watts of power per port. Thirdly, 802.3B, also known as PoE++, provides up to 90 watts of power per port. When selecting PoE equipment for the phone equipment, consider these factors. Firstly, the power requirements of the phone equipment. The PoE equipment must be able to provide enough power to operate the devices. Secondly, the PoE standard supported by the equipment. The PoE standard must be compatible with the phone equipment. Thirdly, the number of ports needed. The PoE switch or injector must have enough ports to connect all of the devices. Fourthly, the distance limitations. The maximum distance for PoE is typically 100 meters. PoE is a viable solution for powering remote phone equipment from a UPS, especially in situations where running separate power cords is not feasible. It simplifies installation, saves costs, and improves reliability. Always make sure to consult with the electrical engineer. If the phone equipment does not support PoE natively, PoE splitters can be used. A PoE splitter separates the power and data signals from the Ethernet cable, providing separate power and data connections for the device. This allows non-PoE devices to be powered by PoE.